Good morning, good afternoon to everyone, and welcome to the Cloud Coaching session. I am Violeta. I'm a part of the Digital Cloud Adoption Managers team in Oracle EMEA. Today, we are happy to be joined by Suraj Ramesh, who is a Principal Product Manager within the Full Stack Disaster Recovery for Oracle Database in Oracle. And we are also joined by Rafael Teixeira, who will help us. I think that was all on my side. Suraj, over to you.
Hello, everyone. Thanks for joining the call. As Violeta mentioned, this is Suraj Ramesh. I work as a product manager for the OCI Full Stack DR, and also I'm responsible for the Oracle Database MA and online redefinition feature. I'm part of the Oracle Database High Availability, Scalability, and Maximum Availability product management team. And these are my social handles. I am pretty active in LinkedIn and Twitter, and also I post technical blogs in my recently newly launched blog. So you can watch out for these details. And also, if you want to connect through social media, you can. Happy to connect. Okay, so I will directly jump into the session of today, right? This is what I'm planning to do, right? Again, this is being cloud coaching. Mostly people are interested to do hands-on or more technical details, right? So I'll try to keep it up, the presentation part as much as less I can. But I just also noticed in the poll which Violeta started, I noticed like around 50-50 people. I mean, they are aware about the service. 50% of the people are not aware about the service itself, and also uh, predominantly, I think 90% of the folks haven't used the feature or not aware about the new features also, right? So I'll try to, spend few minutes extra in terms of the additional, the fundamentals of what full stack DR is. But of course, the main intention of the call is to go through the OCI console to explain about all the new features, what we have done over the last few months, right? So this is my overall agenda. So with this, I'll just directly start with this slide, right? Just to understand like what exactly the service helps, right? So uh, let's assume like you don't have, a full stack DR, or you generally manage a full stack, a disaster recovery plan for your enterprise applications running in OCI, right? We get a lot of customers quote from they don't have enough people to do the recovery on time or without any errors, right? So this is a common problem we've seen across many customers, right? Especially planned is fine, right? Because planned you're doing it on an initially upfront time. But in case of an eventual disaster recovery happen, right? It can happen at any time. You don't have right people do the recovery at right time, right? So that's where the full stack DR helps you to improve on how quickly you can recover your business critical system running in OCI. Okay, so I will start. Okay, again, I'll just spend a couple of minutes of what exactly the service does, right? In case for folks who's not aware about the service or who are understanding or listening for the first time. So this is a fully managed service available in OCI in all public cloud regions, right? So if you're using any one of the public cloud regions, you should be able to use the service today. And what the service does in short, right? So assuming you have two regions, right? Your production region where you host your production application, and then you're replicating all your data at all layers through various technologies available in OCI. Like example, for database, you're using DataGuard, and similarly for infrastructure, depending on the technologies or the services using replication across from production to DR. Then what full stack DR can help you to do is it helps you to recover your application through a single click of a button in a single pane of glass, right? So that's what the service does, right? So primarily it helps you to do the recovery of your application for an entire level, right? Right from app database infrastructure uh, with a single click of a button, right? So that's what in short the service does. And of course, we have a lot of, I mean, technical details about this, which I'll go through in the slides. But in short, as I mentioned, it provides an orchestration framework where you can use full stack DR to recover an entire application with a single click of a button. And while you create services, in our service, we have various plans you can create, right? One of the plan which we recently launched is DR drill, which I'll talk about in detail. We create a lot of built-in intelligent modules, what we call as built-in plan groups in our service. So depending on the type of members you add, the service automatically introspects and it creates a lot of built-in intelligent modules automatically. And then again, as I mentioned, right, it provides an unified management, right? So rather than going through multiple places, assuming if you have implemented full stack DR, if you want to do a switchover or a failover, right, you can just simply go into an OCI console and click one button to perform the recovery process. And along with that, if you want to monitor the execution of what exactly is happening, everything can be done from a single pane of glass. Okay, so I hope this gave a quick idea about what exactly the service is, right? And the next few slides, I will talk about the new features. And before that, I'll just quickly spend a minute about what exactly the service, the core constructs is, right? So we have a construct called protection group. So this is the first thing you need to create when you want to use the service. So this is basically you could consider as a logical container for your entire business system, right? So you need to create a protection group for a specific application or a specific business system in production and the DR region, and then you need to associate the protection group based upon the roles you have, right? So that's the first thing you need to create. The DR protection group is a core construct available within the full stack DR. And once you do that, you can start adding the members, right? So members are basically the OCI resource types which is available, and these are the larger family of member type which we currently support. To start with Oracle database. So if you run any Oracle database using base DB service or Excel database on dedicated infrastructure or autonomous database serverless, you could add a member to the protection group. And similarly for compute family, you can add a virtual machine or a dedicated virtual machine host. And then from a storage perspective, you could add a volume group, which is basically the boot and block volume replication. And the one which are highlighted in yellow are the one which we recently announced. This is where this call is more focused. So I'll spend a lot of time explaining about all these new features. But you could add a file storage service or the file system to the protection group, right? Similarly, you could add a load balancer, right? So if you're using either an application load balancer or a network load balancer, you can add any one of the load balancer to the DR protection groups. So these are the core member types which you currently can add to the protection group. When I mentioned the members, right, I talked in about the built-in intelligent modules. So when you add these member types, depending on how you're configured, then the service automatically introspects and creates those built-in modules automatically, right? So that's the significance of having the member type availability. But of course, beyond this members, in case if you're using any other services, right, like let's say OCI DNS, or other services, PaaS services like integration cloud or analytics cloud, anything, right? You could still involve that recovery process as well. I will explain about that. So we have something called an user-defined group you could add on top of the built-in models which we provide. But these are the significant the automation benefits which the service automatically creates for you based upon the member you add. Okay, so with this, I think I already talked about the association, right? So you need to create the protection groups and then you need to tell to the service which is the primary and which is the standby so that the service understand the role of the protection group, right? So this is the first thing you need to do. I will show it in the demo also about this. And once you add this, we talked about the DR plans type. So you can create switchover plan, failover plan, and also the recently announced drill plans, right? So we support 3 types of plan. Depending on your requirement, you could create all the plan types. Okay, so what I'm going to do next is I'll spend maybe a slide about all the new features, right? So that you understand what exactly the new feature is about. And then I'll directly jump into the OCI console to demo all of these new features, right? So again, as I mentioned, we have member types, new member types. One, you can add a load balancer or the file storage. And similarly, the DR plan types, we recently announced the plan type called DR plan drill. DR drill is something similar to failover, right? But the significant difference of what the DR drill plan is, you can create an isolated environment into the DR environment without touching the production environment itself, right? So that's the beauty of the DR drill plan. So if you have any requirements of any DR drill mock, or you need to perform a DR drill every 3 months or so for your compliance requirements, then DR drill plan would be ideal because we are not touching anything to the production, right? So the production stack will be keep running it, but you are using your DR infrastructure to perform a DR without impacting the production. And once you perform the DR drill, then you can use the stop drill to terminate all the resources or convert back to the original state, right? So that's the beauty of DR drill plans. Without impacting the production system, you can use the DR drill plans. All right, so let me spend additional details about what exactly the DR drill plan, right? I already explained what exactly it does. So once you create, right, you can add members, right? So currently you can add all the member types which we support: compute, volume group, autonomous database service, serverless, file storage, and load balancer. And one important thing which you need to be aware about, example, if you are using a base DB or Excel database, right? When you create a DR drill plan, you'll not be able to see a built-in plan group created for these two base database, two database system, right? Because both the services doesn't have a API or a feature to convert a physical standby to snapshot standby, right? So that is something coming up in future. The database services team are actively working on that project. Once they release it, then we will integrate with those APIs with our service. But as of today, if you use any of these two database and then add as a member to the production group, and then when you create a DR drill plan, you'll not be able to see the built-in plan groups for these two database alone. But again, as I mentioned, right, the service is highly flexible. You can create additional user-defined groups for converting the physical standby to snapshot standby and vice versa, right? So this is an important thing to note, right? Because we get a lot of uh, uh, queries or service requests, customer asking, okay, hey, we have added the base DB and Excel database, right? But they're able to see the built-in plan groups when they create a switchover or a failover plan. But when they try to create a drill plan, right, they'll not be able to see this. The reason, as I mentioned, that the underlying services doesn't have that APIs exposed as of now. So to tackle that, you could create the user-defined scripts to convert those database from physical standby to snapshot standby and vice versa. So once you create the star drill plan, right, it creates a replica of your production stack in the standby region identical to what you create in the switchover or failover plan. The star drill plan is exactly opposite, right? It removes the replica of your production stack, which was created during the star drill plan. Okay, so I will talk about the load balancer member type now, right? So again, similarly to how you add a database compute, you can add a load balancer as a member type to the production group. So you can add both the application load balancer as well as the network load balancer. And the load balancer can be public or private. So it's depending on what you have configured, you can add either of both of them. The significant thing which you need to understand, again, this is for all the member types. You have to pre-provision the load balancer with the load balancer configuration, right? The full stack DR doesn't help you to do the provisioning of the load balancer. So it's your responsibility to create the load balancer, backend cert, listener, SSL configuration. Whatever you need to do as part of your load balancer configuration that has to be created in both primary and the DR region. And once you have that, then you could add the load balancer as a member into the protection groups, right? Again, the load balancer is tied into the application compute VMs, right? So based on that, right, as a dependency, you have to add the respective compute, either it can be moving or non-moving, into the protection group, right? So when you add a load balancer, it is expected to you add the protection, the compute members, the respective compute members, which is part of the load balancer, into the protection group. It can be moving or non-moving, but you must add that compute instances as well to the protection group. So once you add that, these are the tasks which we do, right, during the plan execution. So we remove the load balancer and then add the load balancer backends and then drain. I'll show it in the demo, but ideally these are the high-level steps which we do based upon the compute types. If you are using moving, we will remove the backend servers from the primary, and then we'll add the newly launched backend servers into the DR region, if that is for the movable compute. If you're moving, using non-moving, then we basically drain those backends in the source region, and then we'll set the drain state off to the DR region, right? So these are the steps which we automatically create when you add a load balancer type to the DR protection group. Okay, the next one is a file storage, right? Again, this is a newly launched feature where you could add a file storage service to the protection group. You must add only the primary file storage member to the primary protection group, because once you start creating a replication of the file storage, right, it will be as an available as an unexported path. So you cannot use that replicated file storage. So when you add a member type, it is expected you only add the primary, the protection group, the file storage service only to the primary protection group, not to the DR. And again, file storage is dependent on compute, right? So example, you'll be using the network storage to your compute instances or whatever you're using for the application service, right? So you must add the respective compute VMs also to the protection group. I mean, sorry, as a member type to the protection group. And once you add that, then based upon the plan types you create, then the plan groups will be created automatically by the service. Again, these are the high level tasks. Once the plans are created, we provide steps for restoring the file system and then unmounting the file system from the compute instance and then mounting the file system into the newly launched compute and setting up the reverse replication also, right? So these are the automated steps which we automatically create during the DR plan creation. All right, this would be my final slide. So this is again a new feature. This is useful for if you're using a non-moving instance, right? So in non-moving instance, if you're leveraging the cross-region replication, prior to the feature, customers were leveraging scripts to tackle the block volumes into the newly, I mean, in the target region or the DR region. But with this feature, right, you could also, while you select a non-moving instance, you can say which block volume you want to attach and detach into the non-moving compute. So that is a new feature available with this. And also we have another new feature which we launched where you could specify, there is a small checkbox which I'll show, where you could say start and stop, right? Because we have noticed a lot of customers to save costs, they'll stop their compute instances in the DR region in an active passive setup. So you can simply say a checkbox yes, so that the service automatically generates steps for stopping the compute instance in the source and then starting the compute instance in the target, right? So if you have any such requirement, you could simply select the checkbox depending on your use case. All right, so with this, I will jump into the demo. And I guess you might have received in the chat with all the links of all the new features which I talked about. So I have written exclusive blogs for all the new features with step-by-step document and also a complimentary videos, right? So again, in case if you're not able to follow up everything here, in case if you're not aware about the service, you could simply use those blogs and videos so that all those steps are available in a step-by-step manner where you could try it out. All right, let me navigate to OCI console now. Okay, so what I'm planning to show now is again, setting up this replication and all the things will require additional time, right? So since we have next 15-20 minutes, I'll directly jump into the full stack DR configuration and I'll show the member types how you can add, especially for all the members, new members which I talked about, right? So before that, I would like to just show you the architecture which I'm using. Again, this is part of the live labs, which we have for the full stack DR. I've just used that infrastructure to show this demo. So the architecture which I'm following here is this is basically what we call as an active whole VM DR, right? So it's here I have two regions. Primary is my Ashburn, and then DR is my Phoenix. So in terms of application VMs, right? If you notice, the virtual machines lying in only one region. I don't have any VMs running in the DR region, right? So this is what we call as a moving instance in full stack DR terminology. But in generally, customers or in industry people will call as cold VMDR or pilot light DR, right? So the compute always lies in the production region, and then full stack DR has the capability to launch the compute instance during the runtime operation. So that's for the compute. And for database, I'm leveraging the autonomous data guard to do the replication of the database. So this is something I've pre-created. And for the compute, I've configured the block storage replication so that all the data and the boot and block volumes available from these computes will be asynchronously replicated to the DR region. And also I'm having my object storage buckets to various logs. So that is also replicating across the region. And then, and the load balancer, right? Again, being we have a load balancer member type. I have pre-configured the load balancer in both regions, right? So based upon my requirements, I've configured the load balancer and created listeners in both regions, but the application traffic only will be served to the primary load balancer. In case if this takes over, then the standby load balancer will start serving traffic. The only one member type which is missing here is I have a file system, right? I've created a file system with the replication with using the file system replication feature. And then I've attached the file system into the both compute instance. I will show in my terminal, but that's the only missing piece in this diagram. So I'm going to use this architecture, and then I'll show the member how you can add and how you can create and all the stuffs in the OCI console. All right, so I've logged into OCI console. I have two regions, right? Ashburn and Phoenix. In case if you are not aware how to navigate to the full stack DR, so you can go to the hamburger menu, select migration and disaster recovery, go to the DR protection group. So this is the landing page of the full stack DR service, right? So this is the place you can go there. So I've opened two tabs, right? So this is where you need to start in terms of creating protection group. So creating protection group is really, really simple, right? So you can just click create protection group, provide a name, right? And then select the object storage bucket. An object storage bucket, we ask for storing all the logs. So in terms like we run all the switchover, all the plans, all the logs which we generate as part of the full stack DR will be stored in this object storage. So that's mandatory to provide an object storage, and then you can just simply create, right? So we're just providing couple of inputs, and then you can just create the protection groups. So what I did, I created two protection group, right? So here you can see I've created a protection group called Cloud Coaching IAD. So this is my protection group running in a primary region, I mean my Ashburn region. And similarly, I created another protection group in the Phoenix region. So that's the first thing I've done. And once you did do that, then you need to associate the protection group. So there is a button called this. I mean, here it's search disassociate because I've already associated, but without the roles, you'll get an option as associate. Then you can just simply click associate and then select the roles, right? Primary will be this one, and then you can select the region, and then you can select the respective protection group in the target region, right? So once you do that, then you can hit associate. Within few seconds, you'll be able to see the roles automatically assigned, right? So I've did that. So I've assigned the primary Ashburn region protection group as the primary role. And similarly, in the Phoenix DR protection group is the standby role. So this is the first thing you need to do in order to start the service, right? So once you do that, then you can start adding the members, right? So members, as I mentioned, based upon the resources which you use, or based upon the type of members which you have as part of your business system or your application, you can add, right? Since in this demo, I just want to showcase all the members which we support and also the newly launched features. I've added bunch of features, I mean members, but I'll show you how exactly to add all those things, right? So to start with, I will start with the primary, right? So you could select add member here, right? So in the resource type, you'll see the member types: compute, database, autonomous, database, volume group, load balancer, network load balancer, and file system. Again, like I already added to save time, but just for the new features, right? I'll show you what exactly you need to add in terms of the new features which we talked about. The file system, as I mentioned, you need to add only the file system in the primary region. So it will ask for you the file system. Since I've already added my file system, it is not showing here. So what I'll do here, I'll just select the file system, then click edit. So it will ask for a bunch of details, right? So example, what is your destination availability domain? And then what is your source export path? And what is your destination mount target? So these are the details we pre-populate into the member properties when you want to add a file system, right? And of course, as a prerequisite, you need to set up the replication for the file system from the primary region to the target region. Similarly, I'll show the other member types also, right? Especially for the file system where you want to mount. So I've added these two compute as a moving instance, right? Because as per my architecture, I have selected these two compute as a moving instance. So while adding the moving instance, I have selected the file system. Especially you could do that in the advanced option, where you can select the file system. And in the file system, where we'll ask what exactly the export path is and what is your mount point, and then which mount target you want to unmount it in the primary region, and what is the mount target you want to use it in the target region, right? Again, these are the details you need to provide upfront while you add all these member properties, so that based upon that, we automatically generate the plan groups while you create the plan. And again, the file system is also applicable for non-moving instance also. So it's not only meant for moving. So if you're leveraging non-moving instance, similarly, you could add a non-moving instance also into the file system. And to show the another new feature which we talked about, which is the load balancer, right? I will select the load balancer here. Show edit. So in load balancer, we ask for details like what is your destination load balancer, and then what is your source backend set, and what is your target backend set, right? So again, as I mentioned, we only provide generate steps for the backend servers, which is part of your backend server. So we ask for the load balancer detail and also the source backend set and the target backend set. And here, if you notice, we have a checkbox. So example, in this architecture, I am using for the movable compute. That's why I have unchecked this box. In case if you are using not a non-mobile instance, you must select this checkbox so that we understand you are trying to associate a load balancer for a non-moving instance, right? So depending on what you use, you should modify the configuration according to your requirement. And the last feature which I would like to show as a member property is the non-moving instance, right? Where we have capabilities to add the block volumes, right? Similarly, once you select the non-moving instance, you can go to the advanced option and select the block volumes, right? In the block volume, we'll ask for what is your block volume and what is the volume attachment. And also you can optionally provide a mount point, right? So example, if you have a bunch of other mount points, which is part needs to be done, you could automatically add all these things, right? So in this example, I have just only one block volume and the volume attachment. I've just used this as a reference here. So yeah, this is my primary, right? So I've added all my members in the primary protection group. Similarly, I will go to the standby protection group region, right? And I've added all the members, right? So if you notice the significant difference between the members, we don't have any moving compute, because moving compute always lies in the primary region, right? And also the database, since we have created as an autonomous data guard, you must associate a primary standby database here. And the load balancer also, since it's already pre-created, you must add a load balancer and specify the other way around of the destination load balancer, right? So here, if you select the load balancer, we'll ask the destination load balancer in the primary region. So you have to provide the primary region load balancer and the source backend set and the destination backend set. And again, like for non-moving instance, since I'm leveraging the non-moving instance, I've just added the non-moving instance as a member type here, and which I'll show it here. So if you go to the advanced option, you can go to the block volumes, where I provided the block volume details and the volume attachment reference. Again, it might sound pretty complex here, but the idea to show all the member types is, right, so that you understand what exactly the process you can use to add, but it completely depends on what exact members you use for your application, right? Example, we have customers who just use only the compute, and then they add the volume group on top of it. So if that is the case, you can just use the moving compute or non-moving compute depending on it. But if for the large enterprise application for managing at one place, they would be ideally using all the core services like database, file system, and then load balancer and all the things, right? So I just try to showcase all the member types which we support on top of how you can customize with the new features which I showed. So once you add all the member types, right, then you can go ahead and create the plans. The important thing which you need to understand, maybe I can show it in the live. When you try to create a plan, I'll just give a name, test, and then select switchover plan type. I'm just hitting create, right? So you will get immediately an error saying you cannot create a plan with the role with the primary rate. So we allow only to create a plan only in the standby DR protection group. So since this is a primary protection group, the service doesn't allow you to create a plan in this region. The reason is if there are region outages, right? Let's assume your primary is Ashburn, right? And then your DR is Phoenix. Since our service is also a regional service, we have our own control plane, right? If you have created all the plans and we allow to create the plans in primary, right? And if there is a major outage, then if you cannot use our service, then there is no reason of using the service itself, right? So that's the idea of having all the plan creation execution happens. It happens only from the standby DR protection, right? So that's an important thing to understand. So if you try to create, you'll get an error, but I just thought to show you what exactly and how it will look like. So once you are there, then you can go ahead and create the plan. So again, to save time, I've already pre-created the plans, but creating the plan is super simple. So you can just go to the plans and hit create plan, provide a name. So I'm giving a plan name as test. So you can create all the plan types depending on your requirements. So if you want to create switchover, then you can hit create. Similarly, if you want to create failover, you can provide a name and then hit create. And then if you want to create start drill and then change it here. Maybe I can show one thing here. So if you try to create a plan with stop drill, you'll get a message, right? So the message is a stop drill can be created only after executing a start drill and the DR protection group is in inactive state. So this is a thing as a prerequisite, right? Especially if you want to create a stop drill plan, you must execute the start drill plan and the protection group should be in a state called drill in progress, right? Because the reason is once you create a start drill plan, it will automatically create bunch of resources, right? So example, if you're leveraging a moving compute instance, we create bunch of compute instance. Similarly, if you're adding an autonomous database, we create a refreshable clone database, right? So bunch of things which we create on the fly after creating the start drill plan. So that's the reason we don't allow you to create a stop drill plan upfront. So it can be allowed only during the after executing the start drill plan, and the production group will be in a state called inactive state. Okay, so let me show you the plans, what I have created, right? So I've selected the switchover plan, right? So I just want to show you all the built-in things which we create, right? So these are the built-in modules which I talked about, right? So once you hit this plan creation, the service will introspect, okay, what type of member you have added in both primary and protection group. And based on that, it created all this recovery steps for you automatically in a specific order, which we think will be ideal for your recovery process, right? So all these things are created automatically by the service. So you can determine by simply seeing the built-in plan type, right? Plan group type. So whenever it says built-in, so that's something the service creates automatically once you hit the plan creation tag. Again, like if you want, you can just simply read what exactly it does, but let's just go through it quickly. So being it's a switchover, right? We want to ideally shut down everything in the primary and then redirect the traffic into the DR region, right? So for this member type, we have created a plan group for updating the load balancer backend. So what this step does, it removes the backend available in the backend, backend servers available in the backend set. And then since we have the file system attached to the compute, right? So we unmount the file system from the compute instance. And then I also have a non-moving instance, right? Which I showed in my member type in the non-moving instance. So there is a step to detach the block volume in the primary region. And then we stop the compute instance, right? If you notice here, these two are the moving compute instance, but also in my member property of non-moving, I have selected this checkbox. So that's a new feature I was referring. So if you notice here, there's a checkbox which is showing a start and stop instance on switchover and failover. Since I hit this checkbox as yes, this step has been created as well. Non-moving IID, stop compute instance, this has created. But if you don't want to do that, you can just simply uncheck that. You will not see the step. But in case if you want to reduce cost after you switch over to the other region, you could take advantage of these features as well. And the next plan group is switching the volume group. So since we have a bunch of volume groups, we created a plan group for switching the volume groups. And this is for switching the file system, right? Since the file systems are getting replicated, this will convert the unexported file system into an exported file system. And since we have a autonomous database, there is a switchover for autonomous database. And after this done, then we just going into the DR region, right? So once the database is failed over, we launch the compute instance, right? Being this the moving instance, we create these two compute instances on the fly. And again, I've selected the checkbox in the DR region VM also. That's why I see a start compute instance task. And after that, we have the attached block volume, and then updating the load balancer, then mounting the file system on the compute instance, right? So, but the idea is to whatever things which you do through a manual process, the service automatically creates the plan groups for you. And then on top of that, you could customize the additional things as well, right? So example here, you have an option called add group, right? So in case if you want to, let's say, start your application or whatever you need to do, which we don't provide out of the box, you could simply add the recovery steps here also, right? So what you can do, you can just simply select, let's say, I want to place a recovery step after my start compute instance, right? So I can just simply say start my app, and then you can add a step, right? Where you could provide a step name, and then there are two ways you can run your, complete this thing, right? Either you can use a script or a local, OCI function. So if you're leveraging a script, then basically we ask for a target compute instance. We use a functionality called OCI run command, where you can simply select your region, and then you can provide the local script location and also the compute instance name. So let's say I want to start a script which I placed in slash temp that slot that has such. So again, this is I'm just using as an example of a bash script. It can be any language as long as that script can be executed locally. You can simply plug in the script here, right? And also, if you want to run it as a different user or run with OPC or Oracle, whatever user you want to run, you can simply add it here and then add the step, right? So this is where you have a complete flexibility of bringing additional things which you need to do on top of the built-in modules which we provide, right? So wherever we don't get the built-in modules, right, you can simply add the plan group, and then you could use any of the automation through the scripts or the OCI function, and then you can customize the plan accordingly. All right, so let me show a difference also between what is the difference between a switchover plan and also the failover plan and drill plan, right? I'll go to the failover plan first. The significant difference between the switchover plan and the failover plan is we don't generate any steps or the plan groups in the primary region, right? Because the failover is assumed you want to execute in the DR region, and your intention is to bring your application stack in the DR region as soon as possible. That's why we create only the recovery steps in the DR region, right? Here you don't see any steps which we have seen in the switchover plan, right? So we start with the failing of the volume groups and then autonomous database, file system, launching the compute instance, and then starting the compute instance block and attaching the block volumes, mounting the file system, and then load balancer, right? So the idea is we don't want to have anything in the primary because the primary is down, right? So that's why you see all the plan groups created only in the DR region. The drill will be something ideal, right? But in terms of recovery steps, it will be slightly different, right? Because we would like to take advantage of capabilities which database provide, right? If you notice here, rather than failing of the database, right, we basically create an autonomous database refreshable, right? Because the intention is the drill plan will not have any impact to the production, right? And also, once you complete the drill, we want to convert it back to the original state, right? So that's why we don't touch the production at all. But in terms of recovery steps, it will be almost similar to the failure plan, but only the database, there will be slightly different because database, we create a completely a new clone. But in terms of compute, you'll be able to see similarly like how you've seen in the failure plan, a compute instance, starting the compute instance, restoring the volume groups, restoring the file system. So once you complete this start drill plan, right, again, as I mentioned, right, we cannot create a stop drill plan because I have not executed yet. Once you have the start drill plan, what are things which we create in the start drill plan? The stop drill plan will terminate those resources automatically, right? So that's the thing which I talked about in my slides, how important or how you can easily leverage the stop drill plan. I mean, the drill plans where without touching your production, you could simply use the drill plans and then complete your testing, and then you can move it back to the original state. All right, so I've showed what exactly the plan types and also the new members which we support. And now I will just show you how you can simply execute, right? Again, this is applicable for all the plans, but I just want to show you how you could simply run a pre-check and execute a plan. So if you want to run a pre-check, you can simply hit pre-checks run. So you can select the plan type. So example, if I want to run a pre-check for switchover, I can simply select the plan and then I can hit the run pre-checks. So pre-checks is, as the name suggests, right? We don't run any actual execution. We only do all the necessary pre-checks, which is part of the plan type, right? So here we have tons of pre-checks, right? So based on the members types on the plan groups, there are various pre-checks which we do. So let's say for autonomous database, we'll make sure the data guard is in sync. Similarly, the block volume is properly replicating, and whether we are able to launch the compute instance, and then whether you're able to stop the compute instance. Right? All the things which you ideally do as part of your pre-checks process will be taken care by the pre-checks itself, right? So again, this will take a minute or two. I have an executed pre-check which I can show you, right? So here you see just it's showing as in progress, but I have a succeeded pre-check which I can show you. So this took around 2 minutes 28 seconds. You can see here it took around 2 minutes 28 seconds. So every step which we do, right, we generate the time also, right? So that's why you can see each step how much time it takes. But again, for a pre-check, you can also verify. Like example, this pre-check took 11 seconds. This pre-check took a minute and 15 seconds, right? But also you can see the logs, right? So we have all the options to view the log, download the log, right? So the download log, if you this log will be stored in object storage. So if you want to download a log for any postmortem or you want to verify what exactly, you can download the log, right? So you have all the options from a single pane of glass. Let's assume this pre-check completes successfully, right? So because the pre-checks is running, the protection group is in a state called updating. So we have to wait for the pre-checks to complete before actually executing the plan. So we cannot run a plan now at the time being because the pre-checks is happening, right? Again, you can see a bunch of pre-checks have completed and few are in progress. So once this is done, then the state will return to active. And then if you want to execute a plan, you can just simply click and execute DR plan, and then just create, right? And after it, if you do that, then automatically it will go through the plan groups, right? I just want to show you. Let's just wait for this to complete. But the idea is, assuming if you want to perform a switchover or a failover, just select the plan type and then hit a button. That's it, right? And after that, you can simply monitor the recovery steps for each step. And then if you want to troubleshoot, then you could do that as well, right? So now this is succeeded, right? The pre-checks, and also you could see the plan group also moved into the active state. Now I could come on and execute the DR plan. So if I want to execute, let's say start drill or failover or switchover, I could do that. But since I just completed the pre-checks for the switchover, I'll just go ahead and execute the switchover. Again, if you want to run the pre-checks, you could do, but since I just did that, I will just skip that phase. Then you could simply hit execute DR plan. That's it. So this is the beauty of the having the plan and everything upfront, right? So whenever you want to run a recovery process, assuming if you have everything created and run the pre-checks regularly, right, then you can just come here and execute this button where you can start the recovery process of your entire stack with a single click of a button. Again, we have all the options like monitoring, restarting, right? So again, this is just getting started. Let's assume if one of my step got failed, so I'll get an option to retry or skip, right? So example, uh, you think, okay, I can fix it later, I can do it from the back end, right? You can just take the necessary action and then come here and hit the button retry, right? So that you can make that successful. Or else if you want to skip, you can also have the option to skip it as well, right? So you have all the again mention, or I mean option of observability of doing all the recovery process from a single pane of glass. Again, I don't want to wait for everything to complete because we have a lot of recovery steps, but depending on the number of tasks you have, each task will go there, and then once you complete it, right, this plan will get marked as succeeded, and automatically this role will also transition, right? So if you notice here, this showing as standby and this is showing as primary. But once my plan gets succeeded, uh, since we are doing the recovery, right, then the Phoenix will become primary, Ashburn will become DR. The plan group will also be automatically marked automatically into the respective roles. So this will become primary and this will become standby. Again, I cannot show this now because the plan is in progress. So this has to complete. Once this is completed, you could see that state is also complete. Again, but if you want to see the logs, right, as I mentioned, you can just simply go here and view the log where you can see what exactly the step is happening, right? So here you can notice the backend set from the load balancer is updated successfully, right? Since it is source, we have removed the backend servers from the backend set, but we just log all the details here also, right? So if you notice, this has completed successfully. So it marked this plan group as succeeded, and that it moved on to the next step, right? So you get all the options from a single pane of glass. All right, so I think I have showed all the new features as also with the plan execution, everything through the demo. We have any outstanding questions, Rafael, I want to take? Or you answer?
No, I think we answer all the questions so far.
Okay. Sure. So yeah, I have a few more minutes. Yeah, if you have any questions, you could raise hand. Where if you want to answer verbally, we could do that as well. Or else I will hand it over to Aleta.
That was all on my side. Suraj, any comments you'd like to add before we close the call?
No. Thanks,
No.
folks, for joining. And again, like if you need any further assistant help, or you could reach out to me through LinkedIn, or we also have our Slack channel and similar to what we have in the developer forum. So do let us know if you need any help.
All right. With that, I would like to thank you all for joining us. And we hope to see you soon in the cloud coaching sessions. Enjoy the rest of the day. Bye bye.